about 300 feet long. So the machines are about 400 feet long. So we'll be able to fit 300 feet of it down in the shaft and start mining. And then later on, the last one. Normally, the first 200 feet of it is really the important part that you have to have. That's absolutely vital to start off with. And then you kind of, I don't want to say limp along, but you kind of, you start off slowly, and then once you have everything together, then you put the whole machine together, and then you're ready to really go top production.
So, I don't understand, does it propel itself by pushing off of the tunnel liner?
Yes, yeah, exactly. Those, you can see those numbered shoes, those are the ends of the hydraulic rams. So those shoes push out, and they push right up against the face of the tunnel liner.
So do you have rails that support this?
Yeah, that's what I was going to explain right here. So these two gantries here, what they do is, first of all, it's the area where you take the segments off of the train car, but then it also is the area where you build rail in the bottom of the tunnel. See this first deck here has rubber wheels on it. So the rubber wheels actually run on the from here on back, all the trailing gear runs on the rail that you're building up in this area. So you're just pulling the whole machine along, and for the most part, it's on the rail.
Is the rail the same rail that they were using, the light rail, or just construction rail?
It's temporary construction rail. Yeah, our gist is to try to get in and get things going as quick as we can. And it's not, it's precise enough for our trains to do what you run on light rail cars. That you're required to be pretty precise on those light rails. So over here you can see the operator's cabin on the back side of that machine. So that's where the tunnel boring machine operator works, and there he's got some different view screens that give him a lot of feedback on what's happening in the machine, hydraulic pressures, earth pressures, rates of moving forward, cutter head RPM. Then he also has a guidance system that tells him where he's going. From there he's able to turn and articulate. And
how does he know where he is? Inertial navigation system starts from a known point and plots it from there, or is there some outside reference?
There's the basic way that the system that we use is just no different than traditional surveys. It's just to say that we establish points in the tunnel as we come in, and then we have a laser theodolite that's set up on a point, and all you're doing is turning angles and the points that you've established, and then the theodolite shoots a laser straight forward to a target, and that single line by the angle just to measure from the point to where the tunnel boring machine is, and how he knows where the machine is. There's also inclinometers in the machine that tell the operator how either far up or how far down. Left and right comes from the survey system. And also,
is there a visual path that he is following? I mean, created electronically?
There's an electronic path, but it's not like his visualization isn't that you can see that path. But what he does see is a crosshair of where he should be, and then there's 3 other crosshairs of where his machine is, and in which direction it's looking. So he pretty much knows what's going on in the present, and then he has some indication of where it's going in the future. So that's basically what's happening here. These decks will go kind of back to where this multicolored stuff is here.